learn for the knowledge sake, but to rather think deep of how we can use this as a tool to make changes in our society. And that is the real point of doing this. That's the real point of the sacrifice on the listener's end and the facilitator's end. So tonight we'll be speaking on using effect size in statistic analysis and decision making in research. So help me welcome once again Professor Kaffiu Etsi. You're welcome, sir. You're welcome, sir.
Okay, thank you very much. Thank you very much. It's a pleasure to be up here again. And I always enjoy being with friends from all over the world, from Nigeria, from Uganda, from the United States of America. It's a pleasure, and I trust that we are all going to enjoy today's presentation. So I'm going to go straight to share screen. Okay, thank you very much. We are looking at using effect size in statistical analysis and decision making in research. Okay. So here is what we have for today. We'll have an overview, which is, we'll start with an introduction. We'll look at the nature of effect size, the types of effect size, and interpreting effect size. And it's not going to be a really long webinar, and I trust that we are all going to learn from it. Let's look at the introduction. We'll start with an anecdote and then an inspiration. My computer is very slow today. I don't know why, but we shall go on. I'm still working on it. It's very slow. Okay. Someone was asked to define statistics. He thought for a moment and said, statistics is where you put your head in a hot oven and your legs in a very cold deep freezer, and you shout, on the average, I am fine. Now, when we look at the situation, if you mix a hot oven with a deep freezer, it's going to be warm, so it is going to be fine. But in reality, the head in the hot oven is suffering, and the legs in the cold deep freezer is also suffering. But the person says, on the average, I am fine. Okay. That is what statistics is about. We need to try and give the right interpretation of the information that we have. Statistics can mislead you. So it's very, very important that when we are doing statistical analysis, we make the right decisions based on the right analysis that we do. And that is one of the things we are going to do today. Now let's look at the inspiration. The first one says, heavy rains remind us of challenges in life. Never ask for a lighter rain. Just pray to God for a strong umbrella so you can go through the heavy rain. There is always a useful lesson, and that is attitude. The second one, some people will always throw stones in your path. It depends on what you make with the stones. You either make a wall or a bridge. But remember, one day you may have to use one of them. Also remember that you are the architect of your life. And finally, often we lose all hope and think this is the end. Remember God and pray. It is just a bend and not the end. There is a straight road ahead of you. Thank you for the inspirations. So let's move on to effect size. When we do statistical analysis, we take statistical decisions. We make very serious decisions. And decision making is put into several categories. And we are going to look at one of these categories today. In decision making, you may either use statistical significance or practical significance. So statistical decision making using one of the categorizations will make you go for statistical significance and practical significance. So these are the two we are going to be concerned with this evening. So let's first of all look at statistical significance. Statistical significance. And when we are testing hypotheses, we usually have two types of hypotheses: the null hypothesis and the alternative or alternate hypothesis. So let's look at an example. We may state that the mean age of all level 100 students in the University of Ilorin is 24 years. So that is a guess. So the alternative hypothesis, which we usually indicate as HA or H1, can be the mean age is not 24 years. When we do this, we are doing a two-tailed test, which means the alternative is saying you can have the mean age to be less than 24 years or greater than 24 years. So this is a two-tailed test. You can also have a one-tailed test where you use that only one side, either less than or more than. But when we have hypothesis testing, you always state the null, and then the alternative, and then alternate hypothesis. So you collect data and you test the null hypothesis. After testing the null hypothesis, you take a decision. There are two decisions. Number one, you reject the null hypothesis. When the null hypothesis is rejected, we say the result is statistically significant. Or we say we failed to reject the null hypothesis. So in hypothesis testing, we take one of these two decisions: rejecting the null hypothesis or failing to reject the null hypothesis. Now, when we take these decisions, because we are dealing with probability, there is always the possibility of making errors. And in statistical hypothesis testing, two types of errors have been identified. We have a type 1 error, where you reject a true null hypothesis. We also have a type 2 error, where you fail to reject a false null hypothesis. So these two errors are always associated with hypothesis testing. Hypothesis testing with significant tests have a lot of limitations, and we are going to look at 6 of them. The first limitation is the sample size. When you are doing hypothesis testing and your sample size is very large, you are likely to reject the null hypothesis. And if your sample size is very small, very often we fail to reject the null hypothesis. So in hypothesis testing, we always check the sample size, because the sample size can lead you to make an error. Then secondly, hypothesis testing depends on the level of significance for decision making. The popular levels of significance are 0.01, 1%, and 0.05, 5%. These two levels, 0.01 and 0.05, may not produce the same result. Let's take, for example, you have done your calculation and you have a probability value of 0.02. If your level of significance or your alpha value is 0.01, then you fail to reject the null hypothesis, because 0.01 is less than 0.02. But if your level of significance is 0.05, then 0.02 is less than 0.05 hypothesis. So we have a limitation here, depending on the level of significance that you are taking. Sometimes 0.01, 0.05 will give you the same result, but sometimes they will give you different results. Then the third one is the possibility of error. And we have already seen that when you are doing hypothesis testing, you can commit a type 1 error or a type 2 error. And these are serious errors. If you commit a type 1 error, then your decision and your recommendations will not be good. If you commit a type 2 error, your decisions and your recommendations may not be feasible. So limitations of significant testing are serious. Let's look at the fourth one. The results of significant tests are based on probabilities. And every significant testing is based on a probability that something will happen. And because of that, results cannot be expressed with full certainty. And that is why if your level of significance is 0.05 or 5%, your confidence level is 95%. It's not 100%. But if your level of significance is 0.01 or 1%, your confidence level is 99%. So you notice that it's not 100%. So significant test results cannot be taken with full certainty. So when a test shows that a difference in statistical significance, then what this implies is that the difference is probably not due to chance. Okay. So chance plays a big role when you are doing hypothesis testing. Nothing is taken with 100% certainty. Then if we look at the fifth one, often there are misinterpretations of hypothesis tests. For example, a non-rejection of the null hypothesis implies that there is support for the null hypothesis. For example, our null hypothesis states that the mean age of level 100 students in the University of Ilorin is 24 years. So if you fail to reject the null hypothesis, you are implying that the mean age is 24 years. But what we should remember is that the result is an undecided. We do not have enough evidence against the null hypothesis. So a lot of people misinterpret significant testing results. And the last one, sampling procedure. There are different procedures when you are taking samples to test a hypothesis. We have simple random sampling. We have systematic random sampling. We have convenience sampling. We have stratified random sampling. So we have probability sampling procedures and non-probability sampling procedures. And what happens is that different samples can give you different results. One sample can make you reject the null hypothesis. Another sample can make you fail to reject the null hypothesis. And so every time we are doing hypothesis testing or significant testing, so because of these limitations, there is the use of practical significance. So very often, we look at the statistical significance and compare that with practical significance. And the practical significance comes in terms of effect sizes. Okay. Now, the American Psychological Association, which we often call APA, Publication Manual, 6th edition, published in 2010, section 2.07 has this to say. But I just want to remind you that APA produces a manual which is used worldwide in publications. If you want to publish an article, they'll often ask you, are you following APA results? So the APA actually stands for American Psychological Association. They have a publication manual, which in some quarters is referred to as the manual, the Bible for publications. So what does APA section 2.07 say? 6th edition. It says, for inferential statistical tests, e.g., the t-test, the f-test, and the chi-square test, for these tests include the obtained magnitude or value of the test statistic which will be the T, the F, the chi-square. Then include the degrees of freedom. Include the probability of obtaining a value as extreme as or more extreme than the one obtained, that is the exact p-value, and the size and direction of the effect. So APA is saying that if you are doing inferential statistics, in addition to reporting the probability value, you also have to report the size and direction of the effect. And it further states that for the reader to appreciate the magnitude or importance of a study's findings, it is almost always necessary to include some measure of effect size in the results section. So that is the new thing now in research. When you are doing research where you have to do a statistical decision, you need to include the p-value as well as the effect size. And because of the limitations that we have with the p-value, it is important that you add the effect size. So consider the significant value and the practical value when you are writing your results. So if it is a paper you are publishing, don't only state the p-value, also include the effect size. If it is a thesis you are writing, then when it comes to the relevant chapter, maybe chapter 4, chapter 5, which is the results section, every time you are testing hypothesis, report the p-value and then at the same time report the effect size. That is the new thing in vogue. APA insists that effect size should always be included every time we do hypothesis test. So now, further guidance is provided by Neil 2008. And he says that when there is no interest in generalizing, for example, we are only interested in the results of the sample, there is no need for significant testing. In a situation like this, effect sizes are sufficient and suitable. Then secondly, is giving us a warning that when examining effects using small sample sizes, significant testing can be misleading. So effect sizes should be included. And then thirdly, Neil is saying that when examining effects using large samples, significant testing can be misleading because even a small or trivial effect is likely to produce statistically significant results. So APA and Neil are sounding warning bells to us every time we are doing hypothesis testing. So what is effect size? If we want to define effect size, we will say that effect size is a standardized scale-free measure of the relative size of the effect of an intervention. So it provides information about the magnitude and the direction of the difference between groups or the relationship between two variables. So effect size does not deal only with differences. It also deals with relationships between two variables. So it can be a difference between means, it can be a difference in percentages, or it can be a correlation. So generally, effect size provides the practical significance that we need in statistical testing. Let's look at an example. Okay. Now we are going to look at an experiment that investigated the time of day effect on learning. And the question here is, do children learn better in the morning or in the afternoon? Then we had a group of 1,080 children who were included in the experiment. Half of them were randomly allocated to listen to a story and answer questions about it at 9 a.m. The other half listened to it and heard exactly the same story and answered the same questions at 3 p.m. Okay. Then, after they have done that, they measured their comprehension by the number of questions answered correctly out of 20. So here we have two groups. The first group, we had the 9 a.m. group. The second group, the 3 p.m. group. So here are the results. The mean score for the morning group was 15.2 out of 20. The mean score for the afternoon group was 15.9 out of 20. The difference is 0.7. And when we do a t-test, we got a t-value of 6.84. And the p-value is 0.002. So if you take the 5% level of significance, 0.05 or even 0.01, the result is statistically significant, which means that the morning group did better than the afternoon group did better than the morning group, 15.2 and 15.9. That's fine. But the question we'll ask is, how practical is this difference? The morning group is 15.2, afternoon group is 15.9. So if you look at a difference of just 0.7, not even 1 unit, a difference of 0.7, practically speaking, we will say that there is no difference. But statistically speaking, then we'll come with a result and say, oh, let children do comprehension in the afternoon. That is the recommendation we'll make. But practically speaking, that recommendation may not really be feasible. The difference is only 0.7. So that is how statistical significance and practical significance work. So what are the measures of effect size? We have three main groups. We have the D family, which is the standardized difference between two means. We have the R family, which is the correlation between the independent variable classifications. Then we have the categorical family, which is the association among categorical variables. So most people know effect size as the D family, just the standardized difference between two means, but it's more than that. We have the D family, the R family, and the categorical family. Let's look at what they are. The measures of the D family, we have 7 of them. We have the Cohen's D, which is very popular. Most people know effect size as Cohen D, the difference between two means. Okay. That is not the only one for the D family. We have the Hedges G. We have Glasses Delta. Then we have eta squared. Then we also have partial eta squared. We have omega squared. We have Cohen's F squared. All these 7 are members of the D family. We won't be able to go through them one by one. And that is what I'll leave with you. That you try and do some little research on each one of these. But I'll be giving you some of the formula as we move on. Then we come to the R family. That's one, two, we have 7 of them. You have the Pearson's R is an effect size measure. The coefficient of determination, R squared, is an effect size measure. Eta squared is an R family measure. Partial eta squared is also an R family measure. Omega squared is an R family measure. Cohen's F or Cohen's F squared is also an R family measure. Then Kramer's phi or phi or Kramer's V is also an R family member. So we have 7 members of the R family, 7 members of the D family. Okay. So we have 14. Okay. Now it's all on effect size. Then we come to the categorical family. For the categorical family, the ones we use are odds ratio, Cohen's W, the phi or the phi, depending on where you are from. Then Kramer's phi, Kramer's phi, or Kramer's V. Okay. These are the measures of the categorical family. Okay. So for each one of them, there are situations where we use them. Okay. And that is the study I want each one of you to do. When do we use each one of these? Okay. Now, how do we obtain effect sizes? Generally, there are 2 ways. You can do it manually by using the formula, or you have several softwares. So you ask the software the one you want, and it will produce it for you. For example, SPSS can give you effect sizes. Starter can give you effect sizes. Minitab can give you effect sizes. And there are several of them. Okay. So whatever software you are very familiar with, study the software and find out how effect sizes are produced from that particular software. So manually, you can calculate them yourself. So where the software cannot produce the effect size that you want, then you can obtain it by doing your own calculations. Okay. So let's look at some of the calculations. Okay. This is Cohen's D. Now, when you want to do Cohen's D, let me get my pointer. Cohen's D, you are looking at the difference between 2 groups. Okay. So this is the mean for the first group, the mean for the second group, divided by the pooled standard deviation. And how do you get the pooled standard deviation? It's the standard deviation for the first group plus standard deviation for the second group divided by 2. Okay. Or you can, instead of using the pooled standard deviation, you can use a general standard deviation. Okay. And for the general standard deviation, you have S is equal to N1 minus 1, which is the first sample size, times the variance, plus N2 minus 1 times the variance, all divided by N1 plus N2, you find the square root. So the S that you get here is what you are going to put here, and that will give you the D, and this is Cohen's D. We'll soon see how you interpret the various effect sizes. So this is Cohen's D. Then we come to Hedges G. Hedges G, here we have the mean for the first group minus the mean for the second group divided by the standard deviation. And here is the formula that you use for the standard deviation. Okay. The variance for the first group times the N1 minus 1, which is the sample size for the first group, plus the variance for the second group, then N2 minus 1, all divided by N1 plus N2 minus 2. Okay. And this one will give you an S value, which you are going to put in here, and that will give you Hedges G. Then we have glasses delta. For glasses delta, we are going to have the mean for the first group minus the mean for the second group divided by the standard deviation of the second group. This will give you glasses delta. So we have seen the Cohen's D, Hedges G, glasses delta. Now we are going to look at the next one, eta squared. So eta squared, here we are looking at ANOVA. Sum of squares effect divided by sum of squares total. Okay. This will give you eta squared. Or you have the partial eta squared, which is sum of squares effect divided by sum of squares effect plus sum of squares error. Okay. So you are finding the differences and you are looking at ANOVA table. The sum of squares effect here divided by the total sum of squares, or the partial eta squared, sum of squares effect divided by sum of squares effect plus sum of squares error. Okay. Omega squared. Okay. So for omega squared, you are going to have sum of squares effect minus the degrees of freedom for the effect times the mean square error, all divided by sum of squares error plus sum of squares total. That gives you omega squared. Now, when you come to Cohen's half square, you have the coefficient of determination divided by 1 minus the coefficient of determination, R squared. Okay. That gives you the Cohen's half. So these are formulae that you can use to get the various effect sizes. Okay. Odds ratio. The effect size for the odds ratio is A times D divided by B times C. Okay. So where are the A, D, B, C coming from? Here we have the group, treatment group, and then the control group. So we have the success and then failure. You define your success and you define your failure. So the success is the A here, the treatment group success, then the control group success, then treatment group failure, control group failure. So these numbers are what you put in to get your effect size for odds ratio. Okay. So these are the ways that you can do the calculation. And as I said, whatever statistical software you are using, you can always obtain it in an easier form when you ask them to produce them for you. So how do we interpret effect sizes? Cohen has given us a table which we often use for the interpretation. Okay. So let's look at Cohen's table and see how we can use that for the interpretation. So we look at the effect size type and then where it is used and whether the effect size is small, medium, or large. Okay. So if the effect size is small, it means there's no practical significance. Medium, 50-50. When it is large, then it means there is practical significance. Okay. So for correlation, where you are using correlation, the small will be 0.1, medium 0.3, and large will be 0.5. The eta squared, SPSS will always give you eta squared for ANOVA. You have 0.01, 0.06, and 0.14. Anything 0.14 and larger shows that there is practical significance, practical difference. Omega squared also for ANOVA, 0.01, 0.06, 0.14. Coherence are for the one-way ANOVA, one-way ANCOVA, and regression. Okay. 0.10, 0.25, 0.40. Then we have eta square for multiple regression, 0.02, 0.13, 0.26. Coherence are for multiple regression, 0.14, 0.39, 0.59. Coherence D for t-test, 0.2, 0.5, 0.8. Coherence omega for chi-square, 0.1, 0.3, 0.5. And odds ratio for binary data, 1.5, 2.5, and 4.0. So that table was produced by Cohen to guide in interpreting effect sizes. So whatever effect size that you have, you can always come to look at Cohen's table and interpret it. And especially, you want to see if the effect size is large, either equal to these numbers or greater than these numbers. And that is why we say that the effect size has produced practical significance. So, when we are interpreting, there are some guidelines that we look at. So what are the guidelines for calculating, reporting, and interpreting effect sizes? There are a few guidelines we are going to look at, and that will be the end of it. Number one, choose the most suitable type of effect based on the purpose, the design, and the outcome of your research study. So whatever research questions that you have, look at the purpose. Why? What do you want to find out? And then choose an effect size type that will suit that particular purpose. For example, you want to find out the difference in age for level 100 students in the University of Ilorin, University of Lagos. Okay. So these are two independent universities. So you want to do a significant test, then you do look for practical significance. In a situation like this, you want to see a difference. Then you are going to go to the D family. Coherence D is there. Then you can use Hedges G and whatever else you have for your design and for your outcome. Then you have to be explicit about the type of effect size that is used. Don't only report that the effect size is effect size you have used. That is also very important. Is it from the D family? Is it from the R family? Is it the odds ratio? And whatever one you have, indicate exactly the one you have used. Okay. Then number three, present the effects for all outcomes regardless of whether or not statistically significant findings have been outlined. Now, when you do the statistical test, whether you reject the null hypothesis or you have failed to reject the null hypothesis, no matter what the statistical significance says, please report effect size. Whether it is small or medium or large, please report the effect size, regardless of whether you have rejected the null hypothesis or you have failed to reject the null hypothesis. Then fourthly, specify exactly how the effects were calculated by giving a specific reference or providing the algebraic equation that you have used. Some journals will specifically basically ask you, which formula have you used? So even if you say that you obtain it from a software that you have used. So look at what journals often Right, thank you very much. Okay, we are back. So number 5, it says provide the basic essential data for the major variables. So if you are doing group designs, then you provide the means, the standard deviations, the sample sizes for all the groups for the outcomes at all time points of measurement, in addition to the effect size. If you are doing correlational studies, then provide a complete correlation matrix at all time points of measurement. If you are doing dichotomous outcomes, then you present the cell frequencies or proportions and the sample sizes for all the groups. Technology again. If the computer is refusing to move, it will move anyway. So sorry, I'm waiting for the computer to move so we get the last slide and that will be the end of it. I'm still working on it. It's trying to, okay. Okay, that's the last one. Interpret the effects in the context of other research. So the best comparisons occur when the design of the types of outcomes and methods are the same across studies. Then evaluate the magnitude of the effect based on the research context and its practical or clinical value. Then if effects from previous studies are not presented, then strive to calculate sum. And finally, use Cohen's benchmarks, which I showed you already, Cohen 1988 benchmarks, only if comparisons to other relevant research are impossible. So, colleagues, this is briefly what effect sizes are and how we need to use them. And as I said at the beginning, this is the new thing. We call the new thing in research. When you are doing hypothesis testing, don't only report the significant test result. Always report, in addition, practical significance by including effect sizes in your results. Thank you very much. And this is the end of the presentation. God bless you all. So, Sister Peace, we are done.
Thank you so much, sir. I got that nicely, sister. Thank you. It's time for question and answer. Just as we do usually, if you have a question, you can use the raise of the hand feature, or you go ahead and drop it as a chat so we can read it out for everyone to hear. So please, let's have that done now. If there are questions based on what it was. Unfortunately for me, technology didn't allow me to participate. I missed out of the huge chunk. I think he decided to come back when I have something to say.
But you have the video, so there is no problem.
Yes, so there can always be a playback.
You can always play back, yes.
Yeah.
So everyone, you can always play back. And if there are questions, you can always ask offline.
Okay, thank you, sir, for the opportunity. So if there are questions and you like to ask later, you can also drop it in the WhatsApp platform. With that done, I can't see anyone raising their hands, so it's apparent that people want to ask offline. Or there is no question, which I don't think is the case. Professor, thank you so much for your time. Thank you for the knowledge you shared with us. We appreciate
Thank you so much, ma. Peace.
God bless you greatly, sir.
Thank you
right now,
very
before
much.
we end the session for tonight, as our conference is fast approaching, we'd like to have a little overview of what the conference will be like. So I'll quickly hand over to the LOC chairman to brief us of what we should expect in this year's conference. Over to you, sir.
Hello, chairman, we are waiting.
Good evening, colleagues, senior colleagues, friends all over the world. It has been wonderful time with our professors who have been presenting various topics during this, our webinar. We want to appreciate all those who have contributed immensely to the development of IARIA. I want to commend our presenter, Professor Kafil Ese from University of Cape Coast, Ghana. He has been a silent worker since 2019. Is one of our editorial board. And not only that, he has introduced the association in Ghana and is our representative in Ghana. We want to appreciate you, sir. We've learned more. We have learned from not only from your presentation, we have learned humility, we have shared from your wealth of experience. We pray that God will give you long life. That's my prayer for you. God will give you long life so that we will keep on enjoying and getting more from you, sir, in Jesus' name. We want to appreciate also our friend from Uganda. He's a friend, but even apart from that, he's a friend. We share some things in common. We study the same subject area. I don't need to tell you. Later on, you will know our subject area. You may not know, but I know that we study, and he has been consistent. That's why he's supposed to be sleeping now, but every Saturday, he's always with us. We want to appreciate our friend from Republic of Benin, Mr. Solomon. He was here physically with us in Abuja, Nigeria, during the 2019 conference. We want to thank you for your participation. There's also our friend from Ethiopia. For up to 2 months now, he has been consistently coming and enjoying this program. We believe that all these our friends and colleagues, they will be good ambassadors of IARIA all over the world. I want to also thank our colleagues from Nigeria. We have a 6th geopolitical zone in Nigeria, and I want to tell us that we are well represented in all the 6 geopolitical zones. I believe that with IAIE, there will be transformation in the education sector. Because all of us, we are going to turn ourselves by the grace of God to become innovator. Everybody has something to contribute to make our world better. Tonight, I just want to tell us what we should expect in the forthcoming conference slated for 16th to 20th of November 2020. Actually, the program we have is going to be 4-in-1. It's fully loaded. So I need to tell us what we are to expect. Number one, we are going to have the plenary session. The plenary session, the presentation will focus on innovations in educational assessment. And we are not just going to talk about educational assessment, well, we are going to look at the area of innovation. You see that as we are moving from one century to another, things are no longer the same. And so the theme of the conference this year is redesigning educational assessment for the 21st century. Just as we are attending our webinar, we know that 21st century, there are a lot of predictions. Some of those predictions are already coming to pass. We already spent 20 years already. So, and those predictions, they are coming to pass. So we need to prepare ourselves. Educational assessment will no longer be static. We have to come together during this conference and discuss how do we redesign educational assessment. So you see that there will be having some sub-themes that are not common. You can't even find them in literature, like pass or failure dichotomy in assessment. You may not find them in the literature. So these are things we'll be discussing. How do we set our items? How do we have questions that it will not just be people can even be cheating during the exam period? And you see, with that knowledge, you'll be able to get over the issue of examination practices. So we expect more during our plenary session during this conference. The second aspect is the workshop section. The workshop session will feature 4 aspects. The workshop session will be in depth because we are not going to only feature once. At least 2 or 3 times, you'll find out that one particular workshop will be treated about 2 or 3 times during the conference. The reason we are doing that is so that we can have grasp knowledge. Everybody, whichever workshop you decide to go, you become a master in that area. For example, we have our professor who took us on SPSS about 3 weeks ago. He did justice to that paper. He talked about, but there are still limitations. He told us there are some aspects he has not covered. We may not have the time to look at SPSS during the conference. There are many other software we are going to look at. Whichever software we are going to learn, we will be able to use it effectively. That even after your retirement, if you are no longer lecturing, you will be able to be somewhere and that one will be fetching you money wherever you are. So that is our goal. And that is why when I come to the conference fields, you will see that each of those workshops has a particular amount we are to pay. Now, these are the title of the workshop. We shall be having workshop on application of big data analytical tools in education. The second one will be artificial intelligence in educational assessment. And number 3, we'll be talking about available software for item calibration and data analysis. Then finally, this is also new, secondary school education beyond the traditional classroom. With the COVID-19, our secondary school setting will no longer be the same. Let's come together in this conference, think together, rub mind together, share knowledge together. The third aspect of the conference will be on the area of paper presentation. We shall have the privilege of sharing our research findings. We want to appreciate those who have turned in their abstracts. Many of those titles, they are very, very interesting. I believe that if you attend this conference, you will have a lot of things to learn. So let's make sure that we are there. If you are still writing your paper, please continue. You still have time more. On 31st of October, that is the new deadline for submission of abstract and also submission of full paper. Let's put in our best so that we can share our research finding. Then finally, that's the third thing we should expect. I should not tell you everything. By the time you come for the conference, you will see the third area, because it's not only academics that we are to live for. There are some other areas that we need to look at. So the fourth area of the conference will help us to solve the other needs in our life. Thank you very much for paying attention. About the conference, please look at the flyer. I don't want to take much of our time tonight. You will see the conference field there. We also membership field. One of the workshops will be for those who register fully as an association member. Because somebody is asking, what am I going to gain if I register as a member? So there will be one workshop that will be solely for a registered member. I wish us long life. Thank you very much. God bless you.
Thank you so much for that. Thank you. And I believe if you have further question on how the conference will go, you can also reach out to us on our email info@iaiea.org. You can also send a message on the WhatsApp group. Just keep the information coming. And as I said some weeks earlier, that we love feedbacks. So if there are things you also want us to improve on, please let us know. Can send us a mail or also send it on the WhatsApp groups. It's been a wonderful session tonight, and we are grateful you joined us. Before we just go, let's pray together. Dear Father, we thank you for the opportunity to learn from one another. Thank you for the privilege. Lord, we ask that everything we've learned today give us the courage and the grace to go back and practice. And Father, as we do, give us understanding, perfect understanding of these things, and help us to implement it in everything we have to do. In Jesus' mighty name.
Amen.
Thank you for staying with us till now. Have a wonderful time.
And you too. Thank you very much. Unmute.
We are grateful, everybody. We can exchange pleasantry with one another.
Yeah.
God bless you.
How are you?
Thank you.
Thank God for the job.
So Ajayi, thank you. God bless you.
The Lord will continue to strengthen you. We enjoyed the
No.
presentation. It has been very wonderful.
Thank you very much. We appreciate you. Everybody have been muted so we can greet one another before we sleep. God bless you.